this is Rahul Chaturvedi and you are watching Telecom Notes, and today we are discussing about random access procedure. And before going that, if you have not subscribed this channel, please subscribe it and press the bell icon so that you'll get the notification for the upcoming videos. So let's start from the first slide. First we'll have a look over the overview, that what are the things we are discussing in today's session. So starting from the UE, after getting SSS, PSS, and master information block, as well as the system information block, it reads SIRNTI, that is system information radio network temporary ID, and after that it goes for the random access procedure. Starting with the RAC channel, random access channel, that contains the preamble, and after reaching it to the E node B reads that particular preamble with RARNTI, that is random access radio network temporary ID. After that, E node B just sends TCRNTI, that is temporary cell RNTI, on DLSCH downlink shared channel, having the name random access response. Earlier it sends the request and that's the response from the E node B side. Using TCRNTI, that is temporary cell RNTI, and random number as identifier, UE sends the RRC connection request to E node B on the channel ULCCCH, that is uplink common control channel. After that, E node B goes for the RRC connection set up on DLCCCH, that is downlink common control channel, using the identifier that provides the permanent CRNTI. So that's the overview that we are going to discuss today. And coming to the second slide now, before random access procedure, UE synchronize with the E node B through PSS and SSS. These are the synchronization signals. And UE download the system information through the master information block and system information block. So for the random access procedure, out of the number of SIPs, SIP2 is used for, SIP2 is having the particular parameters that comes inside the random access procedure. The UEs download the system information blocks from the DLSCH downlink shared channel. SIP2 download contains parameters needed for the initial access transmission. So in UE get the SIP2 and it contains SIRNTI, system information radio network temporary ID, root sequence index for Z of 2 sequences having the particular codes, zero correlation zone configuration, PREH frequency, and PREH frequency offset. So coming to the parameters of SIP2, and after that we'll have a look over the random access procedure in detail. So as I have just highlighted with the yellow color, these are the parameters that comes under the random access procedure. One by one, going for the detailing. Radio resource configuration common, used to specify common radio resource configurations in the system information and in the mobility control information. Preambles group A configuration exists, provides the configuration of preamble grouping. If the field is not signaled, the size of random access preamble group A is equal to number of RA preambles. Now number of RA preambles, number of non-dedicated random access preambles. Coming to the power ramping step, that's the power ramping factor that I'll just explain you afterwards in this video. And preamble initial received target power That is the initial preamble power from which the UE sends at the initial stage the preamble to the to the E node B. Preamble transmission maximum number of preamble transmission, RA response window size, duration of RA response window, values in subframes, values SF2 corresponds to 2 subframes. MAC contention resolution timer for contention resolution, value in subframes, value SF8 corresponds to 8 subframes. And maximum HARQ message 3TX4. Maximum number of messages HARQ transmissions used for contention based random access. Now coming to the detailing, starting with the RACH. UE sends the preamble to E node B through the channel RACH, that is random access channel. It carries the random access preamble a UE sends to access the network. It consists of 72 subcarriers in the frequency domain. There are 4 random access preamble formats defined in LTE FDD specifications. So what is preamble? So each cell supports 64 different preamble sequences. Actually the preamble is the Z of 2 sequence having the 0 correlation, and for each and every cell there are 64 different preambles having the correlation with each other. So there are 64 codes of Z of 2 sequences that makes 64 preambles. The E node B can distinguish mobile that are transmitting on the same set of resource blocks provided that their preamble sequences are different. The mobile generates its preamble sequence from the Z of 2 sequences using 3 parameters that the E node B advertises in SIP2. The first is the zero correlation zone configuration, which determines the number of cyclic shifts that the mobile can generate from the single Z of 2 root sequence. In a large cell, the mobile is only allowed to use a few widely spaced cyclic shifts because there would otherwise be a risk of the base station confusing one cyclic shift from a nearby mobile with a slightly different cyclic shift from the distance one. In a small cell, the risk is absent, so the mobiles use a large number of cyclic shifts to take advantage of their mutual orthogonality. The root sequence index identifies the first Z of 2 root sequence that the cell is actually using. The mobile generates as many cyclic shifts from this root sequence as the zero correlation zone configuration allows. Move to the root sequences that follow and continues until it has generated all 64 preambles. Nearby cells should use different Z of 2 sequence indexes so as to minimize the interference between their mobiles' random access transmission. So, by reading all these things, we'll get to know that we are having 64 different preamble sequences, and that preamble sequences are the Z of 2 sequences that depends on the 3 parameters that E node B get from SIP2. The most important one is the zero correlation zone. As I have already told you that Z of 2 sequence is already having the number of codes that are having zero correlation with each other. So out of that particular number of Z of 2 sequences, we'll take out 64 different preambles for each cell. So if I'm just giving that particular 64 different preambles to cell 1 and I give 64 preambles to cell 2, so that particular 64 preambles which I give to cell 2 is maybe differ from cell 1. So now coming to the RE mapping, as you can have a look, we are having the 6 RBs from 1 to 6. So these 6 RBs have been just taken by the random access channel, and these particular 6 RBs have been just taken within the duration of every one frame, that is 10 ms. Okay, so taking out the single one from the 6. So in a single RB we are having the duration of one subframe, and it's that particular RB has been just subdivided into 3 parts in the time domain, that is the cyclic prefix, the preamble sequence, and the third one is the guard period. So 6 RBs are taken by the ratch in every single frame, that is 10 ms. Zooming in the single RB, it occupies the duration of 1 ms. So as you can have a look, we are having the cyclic prefix here. So we put the cyclic prefix length in case of the preambles. So in this table we'll have a look about the preamble formats and having the different durations. The change in the duration is based on the cyclic prefix length, sequence length, and the guard time. As you can have a look, let's take preamble 0, preamble format 0. It's having the CP length of 0.10 ms and sequence length of 0.8 ms. The guard time is 0.10 ms, and it's different for each of these values are different in each and every format of the preamble. So the total is 1 ms, total length is 1 ms, and it's having the typical maximum cell range of 15 kilometers. That means if I am having an antenna and in the radius of 15 kilometers, if any of the UE is accessing or sending the preamble, so it will use the format 0, and out of the 64 Z2 sequences or the 64 preambles, it will take randomly that particular one having the format 0 and send it to the E node B. Just like the other formats also, if it's having the duration, if it's having the radius of 30 kilometers, let's take as an example of the second one. So if it's having the 30 kilometers, within 30 kilometers it can use any of the preamble, but the format of the preamble will be 2. So coming to the ratch now. So UE sends the E node B ratch. The UE randomly selects the random access preamble sequence from the set of sequences available in the cell. The preamble selection is a shift in the Z2 code for the cell. This transmission carries no data bits. The RARNTI is specified by the timing of the preamble transmission. So UE selects a random preamble out of the total 64 preambles based on the timing advance. Okay, now coming to the detailing of the parameters. Let's understand first this particular one. As you can have a look, we are having the random access preamble highlighted. Let it be named as 1. Okay, and the initial power I am just taking it as X. So with the X power, initially UE sends the preamble to the E node B, and at E node B, if it do not receive that particular preamble and it drops in between because it's having the initial power, maybe the power has been just raised to reach to the E node B. So how it will be just going for the power ramping steps. So suppose I am the UE and I am just sending my request to the E node B and I am having X power. After that, if it do not get received at the E node B side and I do not get any acknowledgement, so after the transmission time interval TTI, I'll just let it be Y. After the Y time, I'll just keep on repeating the same preamble with having the power ramping step. So this time I'll just send with the power suppose X plus 2. Okay, so right now I'm just taking as an example power ramping step as 2, initial received target power as X, and the preamble maximum transmission is written over here, that 1 2 3, this is the number of preamble transmission, and preamble transmission maximum means that how much time I will just retry to just reach to the E node B. So let it be 10, suppose let it be 10. So 10 times I can retry and power ramp my preamble to reach to the E node B. So after putting the power X plus 2 now, the power of my preamble has been just increased, and I have just sent to the E node B, and after again the Y time, that is your TTI, I do not get any response or the acknowledgement from the E node B side. That means it do not receive my request or my preamble. So I'll just again power ramp with the X plus 4 power, and I'll just send again to the E node B, and I'll just keep on repeating with this process till I reach to that particular power that E node B is getting my preamble. So right now you can have a look that 1 2 3, so these are the retry times. I'm just keep on going with the same preamble. So after it reached to the retry or till 10, then it will abort that connection, and you have to just go for the new preamble and starting again with the same initial power step with that preamble. Now coming to the E node B working. So E node B detects the preamble transmission. It estimates the uplink transmission timing of the UE, derives the RA-RNTI from the time slot number in which the preamble is received. A temporary CRNTI is assigned to the UE. So E node B, after these particular steps, E node B sends the TCRNTI for the random access RNTI on the channel DLSCH, downlink shared channel, having this message as a name of random access response. So the E node B transmit the random access response on the DLSCH channel. The message carries the timing and uplink resource allocation. The message also includes the backoff indicator MAC header for controlling the backoff duration in the event of the random access procedure failure. So after these two messages, what UE will do, UE will save that TCRNTI, saves the temporary CRNTI, that is cell RNTI, from the MAC data for preamble. Apply timing advance. After applying the correction, after applying the correction, The UE is synchronized in the return direction and can transmit data bus to the E node B. Process uplink resource grant. The E node B assigned uplink resource information will be used to transmit the data to the E node B. And after that, you will send the RRC connection request on the channel ULCCCH. So the randomly selected RA preamble does not enable unique identification of the UE, and it is possible that multiple UEs attempts random access with the same RA preamble sequence on the same RA channel. So the solution for this is the contention resolution phase helps uniquely identify the UE that has been just selected. In this scenario, contention resolution will resolve the random access procedure between UE A and UE B. So for RACH procedure, we are having two solutions. The first one is contention based, the second one is non-contention based. In contention based, the UE will go for RRC idle to RRC connected mode. It go for intra-system handover. Uplink data arrives with UE is in non-synchronized RRC connected state. Downlink data arrives while UE is in non-synchronized RRC connection state again, and the RRC connection re-establishment. While in case of non-contention based, completing the intra-system handover automatically, and after that, in non-synchronized RRC connection state, downlink data starts arriving. Now coming to the contention based resolution, it works in two parts. There are two solutions that can be just provided with the contention based resolution. Starting with the solution 1, we are having two UEs, UE1 and UE2. The preamble sequences are picked up by the UEs in random order. So if the UE1 and UE2 sends preamble 1, preamble 1 means the preamble having the code XYZ that has been just put it as a name preamble 1. So UE1 is also sending preamble 1, UE2 is also sending preamble 1. So E node B do not give access to any of the preamble. It do not reads any of the preamble because it gets confused after getting two preambles. So as per the E node B get confused in this case, so it is possible, it's not mandatory, it is possible that E node B do not provide any TCR/NTI to both the UEs, and after the timeout the UEs again send the preambles. So when the E node B do not provide TCR/NTI to both the UEs, then UE1 and UE2 resend the preambles having the because they are picking preamble randomly from the Z of 2 sequences, or out of 64 preambles it will randomly pick up the preamble 1 and preamble 2 that are different Z of 2 sequences codes. So after that it will just read the preamble 1 for UE1 and preamble 2 for UE2, and it will provide TCR/NTI to both the UEs, TCR/NTI 1 and TCR/NTI 2. The second solution is when the UE1 and UE2 sends the preamble 1, that is the same preamble 1 to the E node B. Out of that it will just read that particular preamble, whether it may be of UE1 or UE2. It will read a particular one. So right now we are taking as an example that for UE1 it reads the preamble 1. The enode B assigns resources via the PDCCH. The PDCCH message is addressed by RARNTI1, that is assigned to UE1 and UE2. So right now the enode B will send the RARNTI1 against the preamble 1 to UE1 and UE2 both. All two UEs receive the message as they were expecting the message on the same RARNTI. UE2 mistakenly behaves that the RA response is meant for it, the RARNTI and the preamble in the message match. UE2 has no way of knowing that the message was not really meant for UE1 only. So UE2 is continuing with the procedure even though that had been just rejected earlier by the enode B. So right now enode B knows that I am just providing the access against the preamble 1. It do not know that whether the UE1 or UE2 are just sending that particular same preamble to the enode B. So after sending the RARNTI1 to UE1 and UE2, it saves the TCRNTI, apply the timing advance, process the uplink resource grant, and sends the RRC connection request to the enode B. So UE2 transmits on the same assignment and collides with the transmission for UE1. It is likely that its transmission will not be received at the enode B as it is transmitting with a timing advance that was not intended for the UE. In this scenario, UE2's message is lost because it is not having that timing advance that has been just sent for the preamble 1. So UE2 also starts a timer awaiting the RRC connection setup message. So from the enode B on channel PH, the enode B accepts the transmission from the UE and acknowledges it with a hybrid ARQ acknowledgement. It sends the hybrid acknowledgement or the hybrid ARQ acknowledgement to UE1 against the RRC connection request, and on PDCCH DCI format 1 containing the TCRNTI1 against the RARNTI1 now, it sends to both the UEs UE1 and UE2. The enode B signal a downlink assignment using the temporary CRNTI1. Both UE1 and UE2 assume that the assignment is for them, as both UEs think they have been assigned temporary CRNTI, cell RNTI 1. Now UE1 and UE2 receive the RRC connection setup message as it is addressed with the temporary CRNTI1, but it also contains the random number 1 that is working as the initial identity. In the first slide I have just told you that the random number 1 or the random number has been just sent by the UE as an identifier. So now based on the random number, the TCRNTI1 has been just allotted to the particular device having the random number or the identifier 1. So RRC connection setup message has been just sent from enode B to UE1 and UE2. Compare received initial UE identity with random number 2, UE2 realizes that it has lost out to another UE solution. So UE1 sends the RRC connection setup complete and go for the further process of signaling. And UE2 again start from sending the new random preamble. So that's it from my side, and let me know if you are having any query regarding this or you are having any suggestions. Thank you.